Hello and welcome to INE CCI Service Provider version 5 Lab Course. Today we will look at the basics of ISIS. Now as you know, ISIS is going to be the core IGP in your CCI Service Provider lab exam. So we would first focus on the basics of understanding how ISIS works, what are the prerequisites for two devices to establish ISIS neighbors, what is level 1 routing, what is level 2 routing, what is a level 1 router, what is a level 1, level 2 router. So we will look at all those basics in today's class. So for some of you guys who do not know me, my name is Rohit Pardasani and I would be your instructor throughout this course. I have 5 CCIs, CCI in route switch, security, voice, collaboration, and service provider. So let's look at the functional overview of ISIS. Well, ISIS is a link state routing protocol. Like OSPF, it is an interior gateway protocol. It was mainly developed in the late 1980s by DEC, which is the Digital Equipment Corporation, and was later standardized by the International Standards Organization, which is ISO. The current version of the standard is 10589:2002. Now, before we look at the routing domain and how ISIS works, the first thing you must identify is how different is ISIS from OSPF. Well, there are a few functional differences between OSPF and ISIS. The first thing is the administrative distance of ISIS is 115 versus OSPF, which is 110. But that's not it. There are more differences with respect to areas. If you look at OSPF, OSPF has multiple areas. We can create multiple areas, and one interface of a router is in one area, and the second interface has to be a part of area 0. That's why the router is called as an ABR. In ISIS, the entire router belongs to one area. It's not per interface, it's per router. The entire router goes inside an area.
So let's in fact draw this out. So if you look at OSPF, let's say if I have router 1 which connects to router 2, maybe I have router 3, router 4, and router 5. So maybe router 1, 2, and 3, they are in area 1. And 3 and 4 belong to the backbone area, which is area 0. And again, 4 and 5 would probably be in area 2. So this is a representation of OSPF. So OSPF has one interface in one area, and the second interface would be in the backbone area. And that router would be called as the ABR. So here R3 and R4 are called as ABRs, and area 0 is called as the backbone area. And if you notice, all areas, all non-backbone areas have to be directly connected to the backbone area through the ABR. Now this is an OSPF, but ISIS is different. The entire router belongs to an area. It's not per interface. So a representation of an ISIS implementation would be, again, maybe I have router 1, which connects to router 2. Then I have router 3, router 4, and maybe router 5. Now this is going to be an implementation of ISIS. Now let's assume that router 1 and router 2 belong to area 1. So the entire router, all the interfaces, they belong to an area. This would be area 1. Router 3, let's assume that this belongs to area 3. And then router 4 and 5, they belong to area 2. So now I have area 1 on the left side. I have router 3, which is completely in area 3. And router 4 and 5, they are in area 2. Now here, it's absolutely no problem. So if you notice, the diagram looks different from OSPF. In OSPF, I had R3's one interface in area 1 and one interface was in area 0. But in ISIS, the entire router belongs to an area. So it's basically different. As far as database is concerned, like in OSPF, your ABR has LSA1 and LSA2 within the area, but it generates an LSA3. As far as ISIS is concerned, it only maintains two databases, one for level 1, one for level 2. Now, all routers in ISIS are by default level 1, level 2 routers. All routers, they're by default. So there are three different kinds of routing in ISIS. We have level 1 routing. We have level 2 routing. So there are two different kinds of routing. Level 1 routing is when you want to reach a destination which is in the same area. Level 2 routing would be when you want to reach a destination which is outside your area, which could be an inter-area or an external route. So in OSPF, if you want to reach the external route, what do? You go to the ABR, right? The ABR generates an LSA3 prefix and sends it to you. Similarly here, what's going to happen, there's no concept of ABR. Every router is considered like an ABR because every router could be an L1, L2 router, which is by default anyway. So there's no concept of backbone area. All areas could be backbone. If you actually want to call some routers as backbone routers, then here in ISIS, consecutive routers which are level 2 routers, so consecutive level 2 routers are called as backbone routers or backbone areas. So here, router 3, which is a level 2 router, would be considered as the backbone router or the backbone area, which is area 3, because I have area 1 transiting area 3 to reach area 2. So there are two kinds of routing in ISIS. We have level 1 routing, which is for intra-area. We have level 2 routing to get out of your area, which could be for inter-area or external routes. Now, there are three different types of routers in ISIS. We have level 1 router. We have level 2 router. And then we have level 1-2 router. Now, what exactly is this? So based on the type of router, that would determine what database you are going to maintain. Now, all routers are by default level 1, level 2 routers, which means they would run 2 SPF or they would maintain 2 databases, one for level 1 routing and one for level 2 routing. So something like OSPF, where in OSPF we have intra-area LSAs, so LSA1, and then we have inter-area LSAs, LSA3, or external LSA, which is LSA5. So here in ISIS, if you are a level 1, level 2 router, think of it like an ABR. If you're an ABR, you would have intra-area LSAs, you would also have your inter-area LSAs. So you would have LSA1 and you would have LSA3. Similarly here, by default, all routers are level 1, level 2 routers. So they maintain both the database. They would maintain level 1 database and they would maintain level 2 database. So they maintain routes of level 1. So they do level 1 routing and they do level 2 routing. So they have all routes. They have intra-area routes. They have external routes. They have inter-area routes. They have everything. That's a level 1, level 2 router. Now you can change the default behavior and make a router into a level 1 router only. So if you configure a router as level 1, in that case, he would only maintain one database, which is the level 1 routing database. He would not have any level 2 routes. So does that mean that he cannot reach the external network or the inter-area routes? He can still reach the inter-area routes. Basically, what's going to happen is that the closest L1, L2 router is going to set the attach bit, which tells the L1 router to create a default route to the closest L1, L2 router. So something like totally stub in OSPF, where the ABR sends a default route to the stubby area. However, here, the L1, L2 router is not going to send a default route. In fact, he's going to set the attach bit, which tells the level 1 router to generate a default route towards the L1, L2 router. So I could configure any router as a level 1 router. In that case, he would only maintain level 1 information, but he will still have a default route to get out of the area. Level 2 routers only maintain level 2 database. So they would maintain inter-area routes. They would have even intra-area routes. Now you may think, what do you mean by intra-area routes? I thought level 2 was just for inter-area. No. Level 2 database can also maintain information about intra-area. However, those intra-area routes would not be seen as level 1, it would be seen as level 2, even though they are in the same area. Let me in fact give you an example. So let's say as of right now, I configure ISIS on all these routers and I don't make any changes. So by default, they all are going to be level 1, level 2 routers. Let's assume that. So this would be a level 1, level 2. 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 And this would be a level 1, level 2 router. This is by default. And now let's talk about the adjacency. Now, what are the basic thumb rules for adjacency? The basic rules for ISIS is that if you are in level 1, level 2 router, then you can establish adjacency with anyone. So if I have router 1 and router 2 both configured as level 1, level 2, they would form level 1 adjacency. So they would have level 1 neighborship and they would have a level 2 neighborship. So if I do a show ISIS neighbors on router 1, I would see two neighbors, R2 as an L1 neighbor and again R2 as an L2 neighbor. So they both would establish two adjacency, level 1 and level 2. So something like, think about it like when R2 gives an update to router 1, he is going to send him an L1 update for his intra area, for his own loopback, and he would also send him an L2 update. However, router 1 is going to choose L1 in the routing table because L1 is preferred over L2. So something like O routes are preferred over OIA. So as of right now, there would be two adjacency between router 1 and router 2. As far as 2 and 3 is concerned, even though they both are level 1, level 2 routers, they will only establish L2 neighborship. So they would only establish level 2 neighborship with each other. They would not form level 1 neighborship. Because for you to establish level 1 neighborship, you must be in the same area. Now R2 and R3, they are not in the same area. So they would not form level 1 adjacency. Similarly, between 3 and 4, even though they both are L1, L2 routers, they will only establish level 2 adjacency. As far as 4 and 5 are concerned, they're in the same area. So they would form level 1 adjacency and they would form level 2 adjacency. So absolutely no problem. Now let's talk about from a route perspective. How are the routes going to be advertised? So let's assume that router 1 has some loopback which he is advertising in ISIS. Let's say it has a loopback 1.1.1.1 and he is advertising that in ISIS. So when R1 gives the routes to R2, R2 is maintaining two databases, level 1 database and level 2 database. Since R2 has two neighbors, which is router 1 as L1 neighbor and again router 1 as L2 neighbor, router 1 is going to send him an L1 update, router 1 is going to send him an L2 update. However, router 2 will only prefer level 1 because level 1 is preferred over level 2. So router 2's routing table will only show level 1 route for 1.1.1.1 as intra area. When router 2 advertises that 1.1.1.1 to his neighbor R3, he is going to send him an L2 update. So basically, even though router 2 has level 1 route in his routing table, in his database, he has the same route in L1 also and L2 also. But he would send R3 an L2 update as an inter area, something like how ABR generates a type 3 LSA and sends to area 0. Similarly here, router 2 sends an L2 update to R3 because he cannot send him an L1 update because they're not L1 neighbors. So he sends him an L2 update to R3. R3 is only maintaining L2 database. I mean, in fact, he does have L1 database, but it's going to be blank because there's no L1 neighbor. So because he's an L2 and L1 router, he maintains both the database, but his L1 is going to be blank because he has no neighbors. So this route 1.1.1.1 on R3 would be seen in the level 2 database. And when he advertises to R4, again, he would send him an L2 update. Now, when R4 advertises that route to R5, would he send him an L1 update? No. Even though they are L1 neighbors, he is going to send him an L2 update. The reason? Because the routes do not belong to area 2. The routes belong to area 1. So R4 is going to give him an inter-area route, which is a level 2 route, update to R5. Now this is what you would see. So if I do a show IP route ISIS on R5, you would see as an L2 update for 1.1.1.1. You would not see it as L1. Now this is by default. But what happens if I just go back and change one of the router? Let's say if I change router 5 to be just an L1 router. If I go and change that, what's the change going to happen? What's going to happen now? If I go and change this to just be an L1 router, in that case, there's going to be only an L1 neighborship between 5 and 4. They would only establish L1 neighborship. Now in that case, what's going to happen? R1 sends an L1 and L2 update to R2. R2 will have in his routing table L1 because L1 is preferred over L2. R2 will send an L2 update to R3. R3 will have the route in his routing table as L2 only because he only has L2 update. R3 will give it to R4 as an L2 update. He has the routes in his routing table as L2. So again, he would have in his routing table as L2. And when R4 gives the update to R5, he cannot give him an L2 update because they are not L2 neighbors. Can he give him an L1 update? No, he cannot give him an L1 update because it's not intra-area. The route belongs to area 1 and R5 is not in area 1, it's in area 2. So the only way R4 can give R5 a specific route is if R4 and R5 establish an L2 neighborship with each other. But because they're not L2 neighbors, R4 cannot give R5 a specific route. So in that case, R4 would set the attach bit and tell R5 that, hey, I cannot give you the route, but here's the attach bit. So R5 creates a default route towards R4, and now he can still reach 1.1.1.1. So this is how ISIS works. And let's go back to our slides and look at the functionalities of ISIS. So going back here, a routing domain may be divided into one or more subdomains. Each subdomain is referred to as an area and is assigned an area address. Routing within an area is referred to as level 1 routing, and routing between areas is referred to as level 2 routing. A device in the OSI terminology is referred to as IS. Basically, think about ISIS as the basic term for IS means router. So it's a router-to-router communication. Now, a router, which is an IS, may operate at level 1, level 2, or both. Like I said before, that they could be a level 1 router, or they could be a level 2 router, or they could be a level 1-2 router. Routers that operate at level 1 exchange information with each other at level 1 only within the same area, basically. Routers that operate at level 2 exchange routing information with other level 2 devices regardless of whether they are in the same area or different areas. The set of level 2 devices and the links that interconnect them form a level 2 subdomain, which must not be partitioned in order for routing to work properly. Like I said before, that consecutive set of level 2 routers are called as backbone routers. Now, how do we configure ISIS? What is exactly the ISIS address format? Now, a router is identified by an address known as NET, which is Network Entity Title. The NET is an address of NSAP, which is Network Service Access Point, which identifies the instance of the ISIS routing protocol running on a router. Now, you can have many nets on a single routing protocol instance. You can have more than one net. Basically, the only reason you would have more than one net statement would be, let's say, if you were doing migration between two providers. The net may be 8 to 20 bytes in length, so minimum of 8 bytes and a maximum of 20 bytes in length. And it mainly consists of 3 parts. Area address. This field is 1 to 13 bytes in length and is composed of high order octets of an address. So basically the area portion is a minimum of 1 byte and a maximum of 13 bytes. The next part of the net is the system ID. This is a 6 bytes long and immediately follows the area address. System ID is something like the router ID in OSPF. It must be unique. It has to be unique within the area. And if you have level 2 routers, or if you have routers running as level 2, then again, between routers, it must be unique in the entire domain. And then finally, we have the end cell, which is the end selector. This is basically 1 byte in length and is immediately followed by the system ID. And it must always be set to 00. So basically, if you look at it, the minimum bytes that a net address could be of is 8 bytes. 7 bytes is fixed because system ID has to be 6 bytes. Your end cell has to be 1 byte. So we have 7 bytes done. We only have 1 byte left for area address, or we could have 13 bytes for area address. So maximum of 20. But 7 bytes are reserved, 6 bytes for system ID and 1 byte for end cell. So at minimum, I could have 1 byte for area address, 6 bytes for system ID, and 1 byte for end cell, totally making it 8 bytes. Or I could have area address as 13 bytes and system ID as 6 bytes and end cell as 1 byte, totally making it 20 bytes. Now, how in OSPF we have different types of LSAs, in ISIS we have different PDU types. PDU is basically protocol data units. There are different types of PDUs. The first one is intermediate system to intermediate system hellos. These are basically exchange between IS routers on circuits on which ISIS protocol is enabled. So as soon as you enable ISIS, they start exchanging IIH, which is again intermediate system to intermediate system hello PDUs. IIH includes system ID of the sender, it includes the area address, and contains the identity of the neighbor on that circuit. Additional information may also be included in your IIH hello PDUs. Now there are 3 types of IIH. We have point-to-point IIH. This is basically used when you have a point-to-point segment between 2 routers. We have level 1 LAN IIH. These are sent on the multi-access circuit when the sending IS operates at level 1 device on that circuit. Basically, if you have a broadcast segment and if you have routers that are running as level 1 router, then you would see level 1 LAN IIH. Then we also have level 2 LAN IIH. These are again sent on multi-access circuits when sending IS operates at level 2 device on that circuit. Again, this basically means that if you have a broadcast segment and you have level 2 routers running in that broadcast segment, then you would see level 2 LAN IIH. The second type of PDUs would be basically LSPs. So we have an IS generates link state PDUs, so LSPs, to advertise to its neighbor and the destination that are directly connected to the IS. So think about this like LSAs, like how a router in OSPF advertises router LSA, which contains the list of all the links that it is directly connected with and running OSPF. Similarly here in ISIS, it advertises an LSP, which is a link state PDU, which basically tells the neighbor that these are all the links which are connected to me. Level 1 LSPs are generated by routers that support level 1. Level 1 are only flooded within the level 1 area. Level 2 LSPs are generated by routers that support level 2. Level 2 LSPs are flooded throughout the level 2 subdomain. An LSP is uniquely identified by the following. So how do you, let's say if I go and take a Wireshark capture, and if I look at the Wireshark capture for an LSP, you would see that it basically consists of the following. It will consist system ID, which is the ID of that router that generated the LSP. Think of this like in OSPF, we have the originator of the LSA. Similarly here in the LSP, you would see system ID, which tells you that this LSP was generated by this unique router. Then we have the pseudo node ID. This value is always 0 except when the LSP is a pseudo node LSP. For example, that in OSPF we have LSA2, which is the network LSA, and that only gets generated when you have a DR segment. Similarly here, that the pseudo node ID by default would be 0, but if there is a DR present, which is called as dis in ISIS, in that case, there would be another LSP, which is the pseudo node LSP, and the ID would always be 1 or more than 0. The LSP number ranges from 0 to 255. It is basically a 32-bit sequence number. The next type of PDU is the sequence number PDUs. This basically contains a summary description of one or more LSPs. There are two types of sequence number PDUs for both level 1 and level 2. The first one is complete sequence number PDUs. These are used to send a summary of an LSP database for a specific given level. So think of this like your link state database in OSPF that everybody maintains the exact same copy. So everybody has the complete information. So here, this is like something similar where a complete sequence number PDU is sent, which basically gives everyone information about the entire summary of all the routes that you should be having. Then there's a partial sequence number PDUs. These are used to send a summary of a subset of LSPs for a given level that a router either has in its database or needs to obtain. Something similar to OSPF. In OSPF, if you remember, there was something called as LSR, link state request, where if you are missing something, you send a link state request, and then you receive the update, a link state update from your neighbor about a specific route. Similarly here, if you are missing something or if you need something, you would send a partial sequence number PDU saying, hey, I am missing this route, and then the neighbor would send you that specific route. So how does ISIS handle new LSPs? So a newer LSP is added to the local LSP database. If an older copy of the same LSP currently exists in its database, it is replaced. So let's say if you send me a new LSP information and my database has the old information, in that case, I would update my local database. The newer LSP is marked to be sent across all circuits except the circuit on which it has received. So if you send me a new LSP, I will update my local database, and then I will send that new LSP across to all the other neighbors except back to you. On a point-to-point circuit, the newer LSP would be flooded periodically until the neighbor acknowledges. On multi-access circuits, it is only flooded once. Basically, if there are 3 routers in the same broadcast domain, then router A would send only the update or the LSP once to the DIS, which is the DR. And it is the DIS's job to send that information to everyone else. So something like the OSPF, where you send your update to the DR and the DR sends the update to everyone. So it is only sent once on a multi-access circuit. However, on point-to-point circuits, it is continuously flooded till you send me an acknowledgement. What about handling of older LSPs? So a router may receive an LSP that is older than the copy of its local database. In that case, I, who have the newer information, would send you the new LSP telling you that, hey, you have the old LSP, here is the new information. So if router A sends an old LSP to router B would mark that and flood that back to router A saying that you have an old LSP, here is the new information. What about LSPs that are the same? So let's say router 1 sends an LSP to router 2 and the LSP is exactly the same. Well, on a point-to-point circuit, if a router receives an LSP which is exactly the same, it would basically be discarded. On a multi-access circuit, again, the LSPs would be ignored. So in short, if you send me an old LSP and I have the newer one, I will send you the update again with the newer information. If you send me a new information, in that case, I will update my database and send that information to my other neighbors. And if you send me an LSP which is exactly the same, I would basically discard that LSP. Coming back to router roles, like we discussed earlier, all interfaces of a router belong to an area. So the entire router belongs to an area. It's not an interface. There's no backbone area concept. Every router could be a backbone router. Basically, consecutive routers running level 2 domain would be called as backbone routers. Again, like I discussed earlier, there are 3 types of routers. We have level 1 router, we have level 2, and then we have level 1, level 2. By default, all routers are level 1, level 2 routers. So level 1 system, this is an intra-area router. It only knows what the local area looks like and will only learn prefixes from its own area. It only maintains level 1 database and only has an SPF tree for its own area. As far as level 2 router is concerned, this is a backbone router that knows intra-area and inter-area. It maintains level 2 database only and runs SPF for just level 2. As far as level 1, level 2 routers are concerned, they perform both the roles. It maintains a separate database for level 1 and a separate database for level 2. It has two SPF trees, one for level 1 and one for level 2. And then lastly, we would discuss the ISI's adjacency. If you remember, an L1 router can only establish neighborship with another L1 in the same area or an L1 L2 router in the same area. It cannot establish neighborship with an L2 router or any other router which is in a different area. As far as L2 router is concerned, it can establish neighborship with another L2 in the same area or different area. It can also establish neighborship with an L1 L2 router in the same area or different areas. As far as level 1, level 2 routers are concerned, they can establish neighborship with another L1 or an L2 or an L1 L2 in the same area or different area. So coming back to this diagram here, I have both these routers, they are in the same area, and since they're configured as level 1, they would only establish level 1 adjacency. If you look at this next diagram, in area 1, the routers will only form level 1 adjacency because the left router in area 1 is only running level 1, even though the right router in area 1 is running level 1, level 2, but they will only establish level 1 adjacency because this router is just level 1. As far as between these two routers, they will only establish level 2 adjacency, even though they both are level 1, level 2, but because they are in different areas, they will only establish level 2 adjacency. As far as these two routers are concerned, again, they would only establish level 1 adjacency is because the router on the right side is a level 1 router only, so they would only establish level 1 adjacency. As far as this diagram is concerned, again, between these two routers, there would only be level 2 adjacency. Here, I would have level 1 and level 2 adjacency because they both are in the same area and they both are level 1, level 2. Here, I would only have level 1 adjacency. Here, I would have level 1. Again, level 1 here. This would be only level 2. This would be only level 2. This would be level 1. And here, I would have level 1 because this router is just level 1. So let's do a quick test and let's look at our routers. So I have two routers pre-configured right now, which is an iOS XZ router and an iOS XR. They both are configured to run ISIs, and they are at this point of time in the same area, so they should establish level 1 and level 2 adjacency. Let's quickly verify these concepts that we have just learned. So here I have two routers, which is router 6, which is an iOS XZ, and iOS XR, which is XR1. They both have been configured for ISIs. Let's have a quick look at the configuration. So I have ISIs configured, and this is my area, and I have my unique system ID and my end selector, which is here, which is always 00. And if you look at XR1, show run router ISIs. Again, XR1 has also been configured to be in the same area with a unique system ID. And I have activated ISIs on its loopback and on the gig was 0x0x0x0.619. In fact, the loopback does not have ISIs activated because it has the passive command. So ISIS is not activated. However, the loopback would still be advertised because we have the passive interface command. Similarly, here on R6, I have the passive interface loopback 0. So I have not activated ISIS on the loopback, but I have only activated on my physical interface, which is gig 1.619. So I have activated ISIS on the link directly connected to XR1. The loopback is not running ISIS, but I've given the passive interface, so they will still learn about each other. Let's check out my OSPF. Let's check out my ISIS neighborship. So if I do a show ISIS neighbors on router 6, I would see XR1 as my neighbor. However, I see two XR1s as my neighbor. The first one is an L1 neighbor and the second one is an L2 neighbor. Now, why am I seeing two neighbors? Because both routers are by default level 1, level 2 routers. And since they are in the same area, they would form both the adjacency. Now, if I actually go to any one of the router, let's say if I go to R6 and I convert that to be just an L1, they would only establish level 1 adjacency. And if I convert that to be just an L2, they would only form an L2 adjacency. Let's first quickly look at my routing table. So if I do a show IP route ISIs, you can see that I have learned the loopback of XR1, even though I haven't activated ISIS on the loopback, but because of the passive interface command, it advertises that loopback. And I have learned that as an L1 update because L1 is preferred over L2. If I do a show ISIS database, you would see two separate databases, one for L1, one for L2. So here you can see that I have an L1 database, I have an L2 database. And here is where you can see that there are two LSPs here. So I have an LSP from router 6 and I have another LSP from the pseudo node, and the ID is 01, which means R6 is my DR, which is called as a DIS. R6 is going to be the DIS on that broadcast segment between R6 and XR1. Similarly here, if I go back to XR1 and do show ISIS neighbors, you can see that I see R6 as a neighbor. However, I don't see two separate entries. I would see here that my neighborship is an L1 neighborship also, and L2 neighborship also. So let me go back and change that. If I actually go back to my router and go to my interface 619 and say ISIS circuit type, let's say level 1. So if I make him into a level 1 router only, by default he's level 1, level 2. And if I do a show ISIS neighbor now, you would only have level 1 adjacency. There's no level 2 adjacency anymore. My routes would only be level 1 again. It's intra-area, so no changes in my routing table. But my database would only now have level 1 information. So he's not maintaining level 2 information anymore. He would only have level 1 information. In fact, these entries should go away in some time. So if we give it some time, it should go away, and I should only see level 1 information because this router is now running as level 1 on that interface. In fact, right now it's not going to go away because globally I have not made this router into a level 1 only. But if I actually go back to my router and globally turn this router into a level 1 router only, in that case, he would maintain only level 1 information. Right now, he's still going to maintain level 1 and level 2 because only one interface is running level 1. The remaining interfaces may still be running level 1 and level 2. So if I actually go back to my router and say globally IS type level 1, if I give it globally, then it should only show me level 1 information, show ISIS database. It should only contain level 1 information, which you can see here, there's no level 2 information anymore. Let me in fact go and change this to be just level 2. So router ISIS and say IS type level 2. And so if I have globally level 2 and on the interface if I have level 1, interface takes preference. So let's go back to the interface gig 1.619 and change that to also level 2. So now if you see XR1 is still running level 1, level 2. R6 is running only level 2. So what kind of neighborship they would establish? Only level 2. Even though they are in the same area. So if I do a show ISIS neighbors, I should only see level 2 adjacency with XR1. And if I go back to XR1 and do show ISIS neighbors, again, I only have level 2 adjacency, even though this router is a level 1, level 2 router, and R6 is just L2, they would only establish level 2 adjacency. Now, even though they're in the same area, level 2 can still have intra-area routes. If I do a show IP route ISIS, even though the loopback of XR1 is in the same area, I would see the routes as L2, even though it's intra-area.